The test sample used in the demonstration consists of 30 grams of gold with particle sizes ranging from -12 mesh to -100 mesh. This means the gold particles vary in size, with the largest pieces being around 1.7 millimeters, -12 mesh, and the finest particles being as small as 0.15 millimeters, -100 mesh. The mixture includes a broad distribution of fine and ultrafine gold, which poses challenges for recovery, as smaller gold particles are more susceptible to being lost in traditional gravity separation methods. Fine gold, particularly -100 mesh, can be difficult to capture due to its tendency to remain suspended in water or get carried away with lighter materials. The test material is carefully mixed to ensure an even distribution of gold throughout the sample, allowing for an accurate assessment of the NEFCO centrifuge bowl's efficiency in recovering both larger and ultrafine gold particles from black sands and other heavy minerals. At 120 RPM, the NEFCO centrifuge bowl generates a force equivalent to 5 times Earth's gravity, 5 gigaseconds. This increased gravitational force enhances gold recovery by effectively separating dense gold particles from lighter materials. The NEFCO centrifuge operates with a water flow rate of 80 gallons per minute, 300 liters per minute, ensuring optimal slurry movement, efficient separation of black sands, and improved fine gold retention within the recovery rings. The actual feed time for the test is 80 seconds, which corresponds to a feed rate of 1.5 tons per hour, TPH. This means that during continuous operation, the NEFCO centrifuge bowl is capable of processing approximately 1.5 tons of material per hour without interruption. The high processing capacity ensures efficient gold recovery, even in large-scale operations where significant amounts of material need to be processed daily. During the 80-second feed time, the material is introduced into the bowl, where it is subjected to centrifugal force at 5 gigaseconds while spinning at 120 RPM. The combination of controlled feed rate and precise water flow, 80 gallons per minute, helps maintain an optimal slurry consistency, preventing material buildup and ensuring continuous separation of gold from black sands and other heavy minerals. The efficiency of the NEFCO bowl allows for uninterrupted operation throughout the day, reducing downtime and eliminating the need for frequent cleanouts, as seen with other recovery systems. This feed rate is ideal for operations dealing with fine gold, as it ensures that even ultrafine particles remain trapped within the recovery rings, while lighter materials are efficiently washed away. Ultimately, the system maximizes gold retention while minimizing material loss and labor-intensive processing. The total wash time for the NEFCO centrifuge bowl is approximately 5 minutes in real time. However, in the demonstration video, this process has been sped up by a factor of 4x4 for efficiency, making it appear as though the wash is completed in just 1 minute and 15 seconds. This acceleration helps condense the visual presentation while still showcasing the key steps of the cleanup process. During the full 5-minute wash cycle, water continuously flushes through the bowl, helping to remove black sands and lighter materials, while ensuring that fine gold remains trapped in the recovery rings. The process begins with the removal of the intake pipe, followed by the installation of the outlet pipe at the bottom of the bowl. Once the plug is removed, water flow is introduced, allowing accumulated material to wash out gradually. The first few minutes focus on clearing out excess black sands, while the final stages ensure that any remaining fine gold settles properly without being lost. The spiral design of the rings aids in keeping gold trapped, even as the surrounding material is flushed out. The controlled and systematic wash process maximizes gold retention while maintaining efficient operation throughout extended processing periods. One of the key advantages of the NEFCO centrifuge bowl is its ability to efficiently process large amounts of material while minimizing the final concentrate volume. Even when processing as much as 40 tons of raw material, the bowl yields only about 1 gallon of concentrates. This extreme concentration efficiency simplifies the cleanup process, reducing the time and effort required for final gold recovery. The NEFCO bowl achieves this by utilizing a combination of high-speed rotation, 120 RPM, generating 5 gigaseconds of force, and a carefully designed spiral riffle system. As material is fed into the bowl, the heavier gold particles are trapped in the riffles, while lighter black sands and other minerals are gradually washed away. The continuous operation of the system ensures that unwanted material is removed in real time, preventing buildup and maintaining a steady, efficient separation process. By the end of the run, only the heaviest, gold-rich concentrate remains in the bowl. This means that whether processing 5, 10, or even 40 tons of material, the operator is left with a highly concentrated, easy-to-handle volume, just 1 gallon, rather than large quantities of material requiring additional refining. This efficiency significantly reduces labor, processing costs, and gold loss. The manufacturing process of the Underflow sluice box differs significantly from traditional drop riffle designs. Unlike standard sluices that rely on turbulence and riffles to trap gold, the Underflow system uses a controlled undertow effect to separate gold more efficiently. Precision-cut, adjustable gates regulate material flow, ensuring fine gold settles while unwanted debris is washed away. Drop riffle sluices, in contrast, depend on gravity and riffle height, making them less effective at capturing tiny gold. As the adjustable gate lowers, very small gold particles settle into the trap while larger sands and rocks are washed away. The dense gold resists movement, staying behind as lighter materials exit. Watch as the gold settles into place while the surrounding material is washed away. The heavier gold particles resist the water's force, staying trapped while lighter sands and rocks continue flowing out. This process ensures that fine gold remains behind, effectively separating it from unwanted debris with precision and efficiency. With the adjustable gate in place, no gold escapes this trap. The system effectively holds even the finest gold particles, while lighter materials are flushed away, ensuring maximum gold retention and recovery. Tiny gold particles, often called flour gold, are incredibly light and can easily be lost in traditional recovery methods. However, with a well-designed trapping system, even the smallest gold flakes settle securely, while larger, lighter materials wash away. By using controlled water flow and proper riffles, fine gold remains captured, maximizing overall recovery efficiency. As water flows through the system, lighter material is actively washed away, blowing right out from under the gold. Due to its higher density, gold remains settled while surrounding sands, silts, and small rocks are carried downstream. The controlled turbulence ensures that unwanted material is continuously moved, preventing clogging while allowing gold to stay put. This process is crucial for maximizing gold recovery, as it relies on the natural weight difference between gold and other minerals. By fine-tuning the water flow and gate settings, you can optimize separation, ensuring that only the gold remains while everything else is efficiently cleared away.
In the initial stage, artisans cut gold pieces into small segments and blend them with mercury, all without employing any form of personal protective equipment, PPE. Following the amalgamation process, the mixture of gold and mercury is further processed by grinding it in a mortar and pestle. This action aims to achieve a homogeneous blend, forming an amalgam paste. During this grinding phase, artisans are in direct contact with the amalgam, increasing the risk of mercury absorption through the skin. Additionally, the mechanical action of grinding may release mercury vapors into the air, further exposing the workers to this toxic substance without the use of any protective measures. Once the gold-mercury amalgam is prepared, artisans proceed to apply it onto the surface of the religious statues. Using their bare hands or simple tools, they spread the amalgam paste evenly across the statue's surface, covering it with a thin layer. This step involves direct contact with the mercury-laden paste, heightening the risk of absorption through the skin. Additionally, any excess paste may be discarded or wiped away, potentially leading to further environmental contamination if proper disposal measures are not in place. Once the amalgam is applied, artisans heat the statue, causing the mercury to evaporate. This process leaves behind a lustrous gold coating on the surface. However, it also releases toxic mercury vapors into the air, posing health risks. These trendy shops utilize mightily technique to extract gold from ore and refine food items. First, the material is mixed with mercury, separating gold from other components. Once the amalgam is created, it undergoes a heating process to evaporate the mercury, leaving behind the precious gold. To address environmental concerns, the shops install water box condenser systems onto their chimneys. As the mercury vaporizes during the heating process, it travels through the chimney and enters the water box condenser. Within this system, the mercury condenses back into liquid form, preventing it from escaping into the atmosphere. This condensed mercury can then be recycled and reused in the extraction process, effectively minimizing mercury emissions and reducing environmental impact. Furthermore, YPS offers stainless steel retorts, which can reclaim up to 95% of mercury from the amalgam. By implementing these practices, YPS aims to minimize environmental impact while continuing its gold refining operations. In the Modular area, TS confronts a substantial challenge. Thousands of artisanal and small-scale coal miners are extracting hot rock rich in gold and silver. The processing process begins in a shed where hard rock is manually broken down into sand containing trace amounts of gold. The sand is then pulverized into fine particles using steel bars inside tunnels. Each cycle involves the addition and reuse of mercury, resulting in amalgam balls that are processed individually to extract the precious metals. The remaining mercury is squeezed out, leaving behind the amalgam balls, ready for further processing. After extraction, the sand is washed to separate it from the precious metals, and the resulting sediment is taken to the cyanide facility for secondary processing. Here, the material undergoes additional treatment to extract the remaining precious metals. Despite efforts to mitigate mercury use, the small-scale miners continue their operations, perpetuating the environmental contamination.
The process begins with the production of anodes. Raw materials like pitch and petroleum coke are baked at high temperatures in the anode bake furnace, reaching temperatures of up to 1,200 degrees Celsius. This process takes approximately 20 days. These baked materials are then used in the reduction cells for the electrolytic process. Once the anodes are baked and ready, they are transported to the anode stacking crane. The next step is the rotting shop, where aluminum stems are installed in the anodes. These stems are placed into a circular cavity in the anodes, and molten steel is poured around their base. This process ensures that the anodes are ready for use in the reduction cells. The rotting shop operates continuously and produces a significant number of anode assemblies daily. The heart of the aluminum smelter is the pot rooms, where the actual reduction process occurs. Anodes, equipped with stems from the rotting shop, are installed in the reduction cells. Anode changing is a pivotal and continuous aspect of the aluminum production process. As anodes burn out due to the extreme conditions within the reduction cells, they need to be replaced systematically to sustain uninterrupted aluminum production. This process is meticulously timed and executed to ensure that there is no disruption in the reduction process. To maintain a steady supply of aluminum, anode changing operates 24 hours a day, 365 days a year. The reliability of power sources is paramount during this operation, as any interruption could lead to significant production delays, making it essential to maintain a continuous, dependable source of energy to power this critical step in the aluminum manufacturing process. Once the reduction process has occurred in the pot rooms, the molten aluminum sinks to the bottom of the pot. The aluminum is then tapped or siphoned into crucibles. The tapping process collects the molten aluminum, which is ready for further processing. The final step in the process involves casting the molten aluminum into various forms based on customer requirements. These forms may include small ingots, large ingots, and sows. Precise temperature control is essential during the casting process to ensure consistency and quality. Automation plays a significant role in maintaining the quality of the cast aluminum. Jewelry has long been an art form that captures the essence of beauty, elegance, and personal expression. The craftsmanship involved in jewelry production has evolved over the centuries, with advancements in technology and a deep understanding of precious metals. One company that stands at the forefront of this industry is Krasvetmet, specializing in machine-woven chains and bracelets made of various precious alloys. Their journey in the realm of jewelry production began in the early 1990s and has since developed into a comprehensive manufacturing cycle complex, covering everything from alloy casting to diamond cutting and finishing. Krasvetmet's product portfolio boasts a diverse array of alloys, including gold 585 and 750 inches, platinum 950, palladium 850, and silver 925. These materials serve as the foundation for crafting exquisite jewelry pieces that cater to a wide spectrum of customer preferences and desires. From the lustrous glow of gold to the understated elegance of silver, Krasvetmet's commitment to quality shines through in every piece they create. A significant aspect of their production is machine-woven chains, which form the backbone of their jewelry line. These chains come in a variety of designs and serve as the canvas for future embellishments and attachments. In total, Krasvetmet's jewelry production includes an impressive repertoire of 30 kinds of base chains. These base chains serve as the foundation for the subsequent creation of 180 different types of chains and bracelets, showcasing the depth of craftsmanship and design that goes into their products. Hollow chain production is one of the flagship focuses of Krasvetmet's jewelry production. Hollow chains represent a unique blend of intricate design and technical precision. Craftsmen meticulously create these chains by weaving and joining precious metal links, resulting in a delicate yet resilient structure. Krasvetmet's commitment to quality is evident in the production of 18 distinct kinds of hollow chains. These chains exhibit a level of intricacy and artistry that is achieved only through a deep understanding of metallurgy and a mastery of the jewelry-making craft. In addition to their hollow chains, Krasvetmet also delves into the world of diamond-cut gold bracelets. Diamonds, with their unparalleled brilliance and allure, add a touch of luxury to any piece of jewelry. The art of diamond cutting involves shaping and polishing diamonds to reveal their unique brilliance. Krasvetmet's skilled artisans incorporate these exquisitely cut diamonds into gold bracelets, producing a harmonious union of elegance and luxury. Krasvetmet's journey into jewelry production began in 1991 with the decision to explore the manufacturing of jewelry at their facility. The first tangible results of this endeavor came in 1994, when they officially embarked on the production of jewelry. The initial offerings included jewelry made of silver 925, showcasing their dedication to producing exquisite pieces in a variety of precious metals. Following this, they extended their expertise to gold and platinum jewelry production in 1996, marking a significant milestone in their journey as jewelry manufacturers. The gold mining process at the KL Gold Macassa site is a fascinating and complex operation that involves several stages, from underground drilling to refining. This mine, located in the mining town of Kirkland Lake in northeastern Ontario, Canada, is known for sitting atop one of the world's richest gold deposits, with a rich history of gold production. Currently operated by Kirkland Lake Gold, this mine has reached a remarkable milestone of pouring 5 million ounces of gold. However, extracting this valuable resource is no easy task due to the extensive overlying rock layers, with over 5,000 feet of solid rock between the surface and the gold deposits. The process of gold mining at KL Gold Macassa begins deep underground, where miners descend over 4,500 feet to access the gold-bearing ore. When they arrive, they are taken through drifts, which are essentially large tunnels, to their designated work sites. Here's an overview of the various steps involved in gold mining at this site. Geological sampling. One of the first steps in the mining process involves geologists collecting rock samples from the underground by drilling deep into the rock using a diamond drill. These core samples are examined to determine the direction for further drilling. Drilling and blasting. Once the optimal direction for drilling is determined, engineers set out a specific pattern for drilling, and the miners come in to drill holes in the face of the drift. These holes are then loaded with explosives. After everyone has safely evacuated the area, the blast occurs, and the tunnel is extended by about 10 feet. This process is repeated to advance further into the ore body. Mucking and sorting. After the blast, muckers come in to remove the debris, which is then sorted. Some of the muckers' work is even controlled remotely from the surface. The sorted ore, which contains the gold, is separated from the waste rock. Tunnel reinforcement. Miners then enter to reinforce the tunnel with screening and rock bolts, using tools like the jackleg drill and stoppers. This is crucial for maintaining the safety and integrity of the underground tunnels. Transportation to the surface. The ore is transferred from the underground area to the ore passes. From there, trucks are loaded via chutes. The ore is then hauled to the surface by skips via the shaft. KL Gold Macassa is also pioneering environmentally friendly practices in the mining industry. They have embraced battery-powered trucks as part of their commitment to reducing emissions and environmental impact. These trucks are more efficient and have a smaller ecological footprint compared to traditional diesel-powered trucks. The ore, initially in large pieces, is crushed into smaller pieces, around 4 inches in diameter. After that, it is transported via conveyor belts to crushers that continue to reduce its size. The final crusher reduces the ore to around 7/16 of an inch, roughly the size of a Cheerio. Grinding and leaching. The ore is then subjected to grinding mills filled with steel balls, which grind the ore into a fine slurry. This slurry is sent into leach tanks, where chemicals are used to extract the gold from the ore. Gold refining. Once the gold is separated from the ore, it is further processed through purification steps. It is heated and mixed with chemicals, then placed in an oven to dry. The result is a gold product ready for the next stages of refining. Smelting and refining. The gold is melted down in a furnace at extremely high temperatures, over 1000 degrees Celsius. The molten gold separates into matte and slag, with the slag containing waste materials. The gold bars are then poured and undergo analysis to determine their gold and silver content, with gold typically comprising 80 to 90% and silver making up 6 to 12%. Packaging and transportation. Once the gold bars are cooled and their composition confirmed, they are weighed, stamped, packaged, and sent to a refinery. The Planet Gold Guyana project is on a mission to assist artisanal and small-scale gold mining communities in implementing eco-friendly, mercury-free technologies to enhance gold yield and profitability. In a comprehensive video demonstration, Deshaun Balenji, the Chief Technical Officer at Conservation International Guyana, guides viewers through the operation of 3 distinct types of equipment that are capable of capturing gold without mercury: the gold kacha, gold cube, and blue bowl. These innovative devices can be employed individually or in combination with other equipment to create an efficient and mercury-free gold recovery process. The gold kacha, aptly named for its gold-catching capabilities, serves as an essential gold concentrator. It is constructed from polyplastic, ensuring resistance to rust and longevity. This simple machine, when combined with a pump, efficiently captures gold without the use of mercury. The gold kacha is easy to set up, requiring only a 220-volt connection and a water source. It can process 1 to 3 tons of material, even capturing fine gold particles as small as powdered gold. This equipment can recover approximately 80% of the gold content from the processed material. The operation of the gold kacha is straightforward but requires precision. Inside the machine, a barrel-like structure houses a bowl with shelves known as riffles. When turned on, the bowl spins, trapping gold from the material in these riffles. To prevent clogging, there is a strainer at the top of the barrel that only allows material 3 millimeters or smaller to pass through. To ensure efficient operation, continuous water addition is essential, helping the material adhere to the riffles. To recover the concentrate, remove the plug in the middle of the bowl, wash the concentrate into the collection container, and then rinse the riffles with the water. The gold cube is another highly effective concentrator that works alongside the gold kacha. It comes with a 12-volt water pump and requires a small water source, consisting of 3 to 4 shelves held in place by a metal frame. The gold cube is designed to evenly distribute the material, create a whirlpool effect on the second shelf to capture gold nuggets, and functions similarly to a sluice box mat. This versatile equipment can process up to 100 kilograms of concentrate per hour and is most effective with particle sizes under 3 millimeters. The blue bowl, in contrast, is a compact and portable piece of equipment, suitable for small-scale operations. It operates on electricity, utilizing a small water pump, approximately half a drum of water, and a stable surface to function correctly. The blue bowl should be set up on a level surface to prevent gold loss. This equipment is designed to capture gold efficiently, particularly when the concentrate has particle sizes less than 1 millimeter. To operate the blue bowl, turn on the pump, allow the water to circulate and swirl, and then gradually add the material as close to the water flow as possible. The heavier gold particles sink to the bottom, while the lighter materials are carried away through the central hole in the bowl. For optimal results, it's recommended to use the gold kacha first to capture gold from the initial material. The concentrate can then be further processed through either the gold cube or the blue bowl to remove more impurities and increase the concentration of gold. The Making of the Flame Ring by Stephen Einhorn, London, is a testament to the enduring artistry and craftsmanship of fine jewelry. Established in Islington, London in 1995, Stephen Einhorn's journey began with a traditional apprenticeship in the East End of London, where he imbibed the values of perfection and craftsmanship. These core values have continued to define the brand's identity, making it synonymous with high-quality, timeless designs. The heart of Stephen Einhorn's operation lies in their workshop, situated directly behind the shop. This unique setup ensures that every piece is not only designed, but also meticulously crafted in-house. It's a blend of time-honored techniques that have endured for centuries and cutting-edge modern technology that enhances their capabilities. These technologies complement the traditional skills, enriching the creative process. Stephen Einhorn takes great pride in the involvement of their customers. Their designs are the result of countless discussions and refinements with meticulous attention to detail. The goal is to create pieces that are not just aesthetically pleasing but also inherently satisfying for the wearer. Each piece is, in essence, a little sculpture, a wearable work of art that brings immense pleasure to its owner. One of the most rewarding aspects of this craft is problem solving. It demands technical prowess and attention to detail, but it is precisely in these minute intricacies that the artistry shines. The commitment to quality is unwavering, as everything is produced in-house to maintain absolute control over the creation process. What sets Stephen Einhorn London apart is their focus on creating designs that are not fleeting fashion trends, but rather timeless pieces with a sense of heritage. These are more than mere accessories. They are investments in British craftsmanship. Owning a Stephen Einhorn piece is not just about having something that looks fabulous. It's about being part of a tradition of meticulous craftsmanship. The process begins with a furnace heated to an extremely high temperature, around 1,200 degrees Celsius, which is necessary to melt the gold. The goal is to ensure that the gold is in a liquid state, making it malleable and ready for further processing. To maintain the purity of the gold, mentions the use of an igniter and an exit route, which are crucial components of the furnace. The igniter plays a role in achieving the desired purity level of the gold, while the exit route helps in regulating the process. A vital part of this process is understanding how to control the flame. It's essential to monitor the flame carefully, because if it's extinguished or the temperature drops significantly, the gold can solidify prematurely, causing issues in the pouring process. Once the gold mixture is deemed ready to pour, it needs to be prepared and checked. It is at this stage that the process is finely tuned, ensuring that the gold is in the optimal state for pouring into molds. When the gold is ready, the operators carefully pour it into molds to create gold bars. It's crucial to maintain a slow and controlled pouring speed to avoid any spillage and ensure the bar's quality. To verify the purity of the gold bars, a sample is taken from the poured gold and sent to a lab for testing. This step helps in ensuring the gold's quality and compliance with purity standards. After pouring, the gold bars quickly solidify. Therefore, it's essential to work efficiently to shape and clean the bars before they become entirely rigid. The gold bars are taken to a table where they are carefully cleaned and shaped to achieve a standardized appearance. It's essential to ensure that the bars are free from any impurities or sharp edges. Each gold bar is marked with a unique identification number, which serves as a record of the number of bars produced since 1990. This information is essential for tracking and maintaining the quality and consistency of the gold produced. The mining industry has undergone significant technological advancements in recent years, and one of the most remarkable innovations is the development of modular diamond and gold processing plants. These state-of-the-art facilities are revolutionizing the way we extract and process precious metals, making the entire mining process more efficient, sustainable, and environmentally friendly. In this article, we will explore the concept of modular processing plants, their advantages, and the significant impact they have had on the mining sector. Traditional mining operations are often characterized by large, centralized processing facilities that require substantial time, resources, and infrastructure to set up. The construction of these plants is time-consuming and expensive, and they are often fixed in a single location. As a result, mines are often located in close proximity to these centralized facilities, which can limit their accessibility and operational flexibility. The concept of modular processing plants emerged as a solution to address these challenges. These plants are compact, self-contained units that can be easily transported to the mining site. The idea is to bring the processing plant closer to the source, minimizing the time and cost associated with transporting raw materials over long distances. Mobility. Perhaps the most significant advantage of modular processing plants is their mobility. They can be transported to virtually any mining site, enabling mining operations in remote and previously inaccessible locations. This mobility reduces the need for extensive infrastructure development and the associated environmental impact. Cost efficiency. Modular processing plants are cost-efficient in various ways. Their compact design reduces construction costs, and their mobility eliminates the need for permanent infrastructure at the mining site. This results in significant savings in both initial investment and ongoing operational expenses. Environmental impact. The reduced need for infrastructure and transportation also contributes to a lower environmental footprint. Less land disturbance and lower emissions from transportation are just two examples of how modular processing plants support more sustainable mining practices. Faster deployment. Traditional processing facilities can take years to construct, whereas modular plants can be assembled and operational in a matter of months. This speed not only accelerates the start of mining operations, but also allows for quicker responses to market demand fluctuations. Customization. Modular processing plants can be customized to suit the specific needs of each mining site. This flexibility ensures optimal processing performance and enhances the recovery of precious metals, ultimately increasing the efficiency and profitability of mining operations. Increased accessibility. Modular processing plants have unlocked access to remote and previously untapped mineral reserves. This expansion of potential mining locations has the potential to revitalize struggling communities and economies. Rapid deployment. The ability to set up processing plants quickly has proven vital for responding to changing market dynamics. In cases of surging demand or price spikes, mining operations can be swiftly established to meet the needs of the market. Environmental responsibility. Modular processing plants align with the growing emphasis on sustainable mining practices. Their reduced environmental footprint, both in terms of infrastructure and transportation, contributes to the industry's efforts to minimize its impact on the planet. Enhanced profitability. The combination of cost efficiency, customization, and quicker deployment results in increased profitability for mining companies. These advantages have made modular processing plants an attractive investment in the sector. The Carao mine in Botswana is a remarkable example of the success of modular diamond processing plants. This mine is renowned for its large, high-quality diamonds, and the introduction of modular processing facilities has been a game changer. The Carao mine implemented a custom modular processing plant to recover diamonds more efficiently and effectively. The flexibility of the modular design allowed for the integration of advanced diamond recovery technology, which significantly increased the yield of large, high-value stones. Moreover, the mobility of the plant facilitated quicker responses to market demands for specific diamond sizes and qualities, further boosting the mine's profitability.